Applications: Transformations of trigonometric functions. In this video, you will look at how to use transformations to sketch the graphs of primary trigonometric functions that have been expressed in radians. We will put to work what we've learned in the previous two videos. In the previous video, you looked at graphing a trigonometric function using the 5-point method. We will use this 5-point method in this lesson or video. There's a formula which we will also use, as it is very useful. xy maps onto x over k plus d, ay plus c. These letters come from the equation y equals a sine kx minus d plus c. Now, let's look at how to use them. Here is a sample problem that we're going to work through now. The following transformations are applied to the graph of y equals sine x, where 0 is less than or equal to x, which is less than or equal to 2 pi. This information sets the domain for the function. We have to have the graph between 0 and 2 pi. We have a vertical stretch by a factor of 3, a horizontal compression by a factor of 1/2, a horizontal translation to the left by pi over 6, and a vertical translation 1 unit down. As we stated earlier, the domain 0 is less than x, which is less than 2 pi, gives us the initial value for x of 0 and the ending value, or the last value for x of 2 pi. To do this, we're going to create a table of values for the 5 key points for this parent function, y equals sine x. We need to make 2 columns and 6 rows. We're going to label the first column x and the second column y. We are then going to enter the default values for the 5 points that we explored in the previous videos for sine x. So we will have 0, 0, pi over 2 and 1, your maximum point, your midpoint, pi and 0, your minimum point, 3 pi over 2, negative 1, and your ending point, 2 pi and 0. From there, we're going to link the clues given in the question to the parameters, or the letters, within the trigonometric function statement. A vertical stretch by a factor of 3. This means that A will equal 3. A horizontal compression by a factor of 1/2. This means that K represents a horizontal compression of 1/2. A horizontal translation to the left by pi over 6 gives us the value D equal to negative pi over 6. And a vertical translation 1 unit down represents the C value, which is negative 1. When we're done the graph, we need to come back and verify that we do have these values. Step number 4, write the equation. Y equals 3 sine 2, bracket, x plus pi over 6, bracket, bracket, minus 1. This is taking the values that we've discovered in the question and use the clues to find the letters that they represent, substituting for the function. Step number 5. Using the values of a, k, d, and c, a is equal to 3, k is equal to 2, d is equal to negative pi over 6, and c is equal to negative 1. Apply the formula that was introduced at the beginning of the lesson. Just to refresh, xy maps onto x over k plus d, ay plus c. Now, we will keep our values close by and we'll keep the formula close by. We will take our table of values and we will increase it by adding a third column in which we will show our calculations. For the starting point, if we take the formula, substitute in our numbers, 0 for x, k is 1/2, d is negative pi over 6, a is 3, y is 0, c is negative 1, we will get negative pi over 6, negative 1. Same thing for the maximum point. X is pi over 2, k is 1/2, d is negative pi over 6, a is 3, y is 1, c is negative 1, which is pi over 12 and 2. Third point, x is pi, k is 1/2, d is negative pi over 6, a is 3, y is 1, c is negative 1. We get the point, pi over 3, negative 1. The fourth point, the minimum point. X is 3 pi over 2, k is 1/2, d is negative pi over 6, a is 3, y is 1, and c is negative 1, gives us 7 pi over 12 minus 4. The 3 in the bracket, of course, I said 1. It should have said negative 1. And the end point, x is 2 pi over 1 times k, which is 1/2, minus d, which is minus pi over 6, 3 times 1. We get the answer 5 pi over 6, negative 1. Now, let's see if we're right. Plot your points on your graph and verify your answer. So I've drawn my graph, and let's review the points. The starting point is negative pi over 6, negative 1, correct? The maximum point, pi over 12 and 2, correct? Pi over 3, negative 1, correct? 7 pi over 12, negative 4, correct? 5 pi over 6, negative 1, correct? And just to verify, the axis of curve, C is at negative 1, fabulous. The amplitude is equal to 3, spot on. The starting point D is at negative 6, negative 1. So D is negative pi over 6. Fabulous. And cross your fingers, this is the last one. The period length is pi. Now you are ready to take the lesson 4 quiz. Remember to refer back to the videos provided if you need more detail.